Hello everyone. In this lesson I'll solve the ministerial question of lesson 4.1 first derivative test. Question number 1. Find the critical point of the function f of x equal x plus 1 to the power 5. Find the derivative of this function first. 5x plus 1 to the power 4 times the derivative of the inside the bracket 1. Set it equal 0 and find the value of x. Divide both sides by 5, x plus 1 to the power 4 equals 0. Take the fourth root for both sides, then x plus 1 equals 0, then x equals negative 1. Choice B. Question number 2. Also find the critical point of this function. F prime of x equal to 2x minus 8. Set it equals 0. Factorize by 2. X minus 4 equals 0. Divide both sides by 2. Then x minus 4 equals 0. X equals 4. Choice D. Question number 3. Find the critical point of this function. F of x, open this bracket, x power 2 times 3, 3x power 2, x power 2 times x, negative x power 3. Differentiate this function, f prime of x equal to 6x minus 3x power 2. Set it equals 0. Factorize by 3x. 6x divided 3x, 2 minus x equals 0. Either x equals 0 or 2 minus x equals 0. It means x equals 2. There is two critical points, 0 and 2, both A and C. Choice D. Question number 4. Find the critical point of this function. Find rewrite f of x equal to x to the power 5 over 5 minus 5x over 5 equal to 1 over 5x to the power 5 minus x. Differentiate this function, f prime of x equal to 5 times 1 over 5, 1, x to the power 4 minus 1. Set it equals 0. Then analyze difference of 2 square, x power 2 minus 1, x power 2 plus 1 equals 0. Analyze difference of 2 square to the first bracket, x minus 1, x plus 1, x power 2 plus 1 equals 0. This bracket, we don't get any critical point from it since x power 2 equal negative 1 give that x equal negative positive square root negative 1, not a real number. Or x minus 1 equals 0, then x equal 1. Or x plus 1 equals 0, then x equal negative 1. Therefore, there is two critical point, negative, positive 1. Question number 5. Find the critical point to this function. F prime of x, differentiate 3x power 2, set it equals 0. This give us x equal 0. There is one critical point, choice A. Question number 6. Find the local minimum point of the function 6x power 2 plus 12x. Differentiate this function, f prime of x equal to 12x plus 12. Set it equals 0. Factorize by 12. X plus 1 equals 0. Then divide both sides by 12. X plus 1 equals 0. X equals negative 1. X equals negative 1. It is a critical point for this function. This is negative 1. Find the sign of the derivative before and after this value. Before -1, take -2, 12 times -2, -24 plus 12, it is negative value. For 0, 0 plus 12, 12 positive value. Then -1 is a local minimum value for this point. Let us find the y coordinate of -1. 6 times -1 square, 6, minus 12 minus 6. Then the point is -1, -6. Choice A. Question number 7. Find the critical value of f of x equal x plus 1 over x. Find the derivative of this function f prime of x equal 1 minus 1 over x squared. Set it equal 0. Then 1 over x squared equal 1. Then x squared equal 1. Then x equal negative positive 1. Choice A. Question number 8. Find the critical value of the function f of x equal x plus 4 over x. F prime of x equal to 1 minus 4 over x squared. Set it equal 0. Then 1 equal to 4 over x squared. Then x squared equal 4. Then x equal negative positive 2. Choice A. Question number 9. Find the critical value of this function f prime of x equal to the denominator x plus 1 times the derivative of the numerator minus the numerator times the derivative of the numerator over the denominator square. Simplify this derivative, x plus 1 minus x plus 1 over x plus 1 squared. Negative x with positive x equal to 2 over x plus 1 squared. Set it equal 0. This gives us 2 equals 0. Contradiction. There is no value, make the derivative 0. But the derivative is undefined at -1. So -1 is the critical value if -1 is within the domain of the function, but -1 is not in the domain of the function. Therefore, there is no critical point to this function. Choice D. Question number 10. F of x equal cosine x over 2. Find the derivative of this function, f prime of x equal to negative sine x over 2 times derivative of the angle 1 over 2. Set it equal 0. Then simplify this derivative, negative 1 over 2 sine x over 2 equal 0. Divide by negative 1 over 2, then sine x over 2 equal 0. We know that the sine is equal 0 when the angle equal to n pi, where n is any integer number. Then we set x over 2 equal to n pi and find the value of x equal to 2n pi. Since we want the critical value only in the interval 0 to, then we take n1 because 0 is not within the interval. If we take n0, then x equals 0, 0 not in the interval. If we take n1, then 2 pi, it is also not within the interval. Therefore, there is no critical point in this interval because the critical point are x equals 0, 2 pi, and so on. Question number 11, find the critical value of this function. Find the derivative of the function f prime of x equal to 3x power 2 minus 6x times e to the x power 3 minus 3x power 2. Set it equals 0. Since e never been 0, therefore we have only 3x power 2 minus 6x should be 0. Factorize by 3x, x minus 2 equals 0. Either x equals 0 or x minus 2 equals 0, it means x equal 2. There is two critical values, 0 and 2. Choice D. Question number 12. Find the critical value of this function. F prime of x equal to the first function times the derivative of the second plus the second function times the derivative of the first one. Set it equals 0. Reduce x with x. Then 1 plus ln x equal 0. Then ln x equal to negative 1. Then take the exponential for both sides, e to the ln x equal to the e to the negative 1, e to the ln x, it is x equal to 1 over e. Choice A. Question number 13. Find the critical value of the function f of x equal x power 2 minus 6x. F prime of x equal to 2x minus 6. Set it equals 0. Factorize by 2. X minus 3 equals 0. Divide both sides by 2. X minus 3 equals 0. X equal 3. Choice D. On which interval, question number 14, on which interval f of x equal negative absolute value x minus 5 plus 3 is decreasing? Rewrite this function as f of x equal to piecewise function negative bracket x minus 5 plus 3 when x greater than or equal 5 and x minus 5 plus 3 when x less than 5. Differentiate this function f prime of x equal to negative 1 when x greater than or equal 5, 1 when x less, negative 1 when x greater than 5, 1 when x less than 5. Since the limit when x approach to 5 from right is negative 1 and the limit when x approach to 5 from left is 1, therefore the derivative of the function has no limit when x approach to 5 and x equal 5 is a critical point for this function. Now find the sign of the derivative before and after 5. When x greater than 5, the value is negative. When x less than 5, the value is 1, is positive. Therefore, the interval of decreasing is from 5 to positive infinity. Choice D. Question number 15. On which interval the function f of x equal x power 3 minus 3 over 2x power 2 is decreasing? Find the derivative of this function. F prime of x equal to 3x power 2 minus 3 over 2 times 2 times x. Set it equals 0. Reduce 2 with 2. Then 3x power 2 minus 3x equal 0. factorized by 3x, then x minus 1 equals 0, either x equals 0 or x equal 1. We have two critical value. Find the sign of the derivative before and after this value. This is 0 and this is 1. When x less than 0, negative 1, 3 times negative 1 square, 3 plus 3, it is positive. When x between 0 and 1, 1 half, 3 times 1 half square, 3 over 4, minus 3 over 2, it is negative value. When x greater than 1, 2, 3 times 4, 12, minus 6, it is positive value. Then the interval of decreasing is from 0 to 1 open interval. Choice B. Question number 16. On which interval the function is decreasing? Find the derivative of this function f prime of x equal 3x power 2, the derivative of the power minus 12x times the function e to the x power 3 minus 6x power 2 plus 8. Set it equals 0. Since this term is never been 0, then 3x power 2 minus 12x should be 0, factorized by 3x, then x minus 4 equals 0. Either x equals 0 or x equal 4. Find the interval of increasing and decreasing by finding the sign of the derivative. This is 0 and this is 4. Before 0, take negative 1, 3 minus 3 plus 12, it is positive. This value is always positive. Therefore, here we have the interval of increasing between 0 and 4. Take 1, 3 minus 12, negative value. Greater than 4, 5. Take 5, 5 power 2, 25 times 3, 75 minus 60, it is positive value. Therefore, the interval of decreasing is 0, open interval 0, 4. Choice B. And also you can see the interval of increasing and decreasing are always open interval. So already this choice and this choice are wrong. Question number 17. On which interval the function f of x equal 5 minus absolute value x minus 5 is increasing? Rewrite f of x as piecewise function 5 minus x minus 5 when x greater than or equal 5 and 5 plus x minus 5 when x less than 5. Differentiate this function f prime of x equal to negative 1 when x greater than 5 and 1 when x less than 5. The limit of the derivative when x approach to 5 from right is negative 1 and from left is 1. Therefore, the limit does not exist and this function is not differentiable at 5. Therefore, x equal 5 is the critical point since the derivative not exist at 5. Now, find the interval of increasing and decreasing by finding the sign of the derivative before and after 5. When x greater than 5, the derivative is negative 1. When x less than when x less than 5, the derivative is 1, positive. When x greater than 5, the derivative is negative 1, negative. Therefore, the interval of increasing is from negative infinity to 5 open interval. Negative infinity to 5 open interval. Question number 18. On which interval the function is increasing? Also find the derivative of this function. F prime of x equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator 1 over denominator square. Reduce x with x, then 1 minus ln x over x power 2, set it equals 0, then 1 minus ln x equals 0, then ln x equal 1. Equal 1. Take the exponential for both sides. E to the ln x equal to the e to the 1. This means x equal to the e. Find the sign of the derivative of this function before and after e. Before e, since the function is f of x equal ln x over x, then the domain start from 0, since ln defined for the value greater than 0. Therefore, we start from open interval 0, take 1, ln 1 0, 1 over 1 positive value. When x greater than e, take 3, 1 minus ln 3, negative value over positive value, negative value. Therefore, the interval of increasing is open interval from 0 to e. Choice C. Also, as you see here, the derivative is undefined at 0, but 0 is not within the domain of this function. Therefore, 0 is not a critical value. Question number 19. On which interval the function f of x equal x power 2 minus 6 is increasing? F prime of x equal to 2x minus 6. Set it equals 0, factorize by 2, x minus 3 equals 0, then it means x equals 3 is critical point for this function. Find the sign of the derivative before and after 3. When x less than 3, take 1, 2 times 1, 2 minus 6, negative value. When x greater than 3, take 4, 2 times 4, 8, 8 minus 6, 2, positive value. Therefore, the increasing interval is from 3 to positive infinity. Choice A. Question number 20. It is the same function of the previous question, but the needed is decreasing interval. Decreasing interval is from negative infinity to 3. Choice C. Question number 21. On which interval the function f of x equal 1 minus cosine x over 2 is increasing over negative pi to pi? F prime of x equal to negative cosine x over 2, it is sine x over 2 times 1 over 2. Set it equals 0, then divide both sides by 1/2. It means sine x over 2 equal 0. The value makes the sign 0 are n pi, where n is integer, so set m pi equal to x over 2. Since the graph of the sine is this shape, 0, pi, 2 pi, and so on. Find the value of x. It means x equal to 2n pi. When n equals 0, then x is 0. When n equal 1, then x equal 2 pi. When x equal 2, then x equal 4 pi. If we take from both sides negative and positive, we have negative positive 2 pi, negative positive 4 pi, and so on. Therefore, between negative pi and pi, this is pi, negative pi, this is pi. We have only one value make the sign 0. It is 0. X equals 0. Therefore, we find the sign of the derivative before and after 0. Find the sign of the derivative before and after 0. Before 0, between negative pi and 0, take negative pi over 2, negative sign negative pi over 4, it is negative value. After 0, take pi over 2, pi over 2 over 2, pi over 4, pi over 4 is positive value. To pi. Therefore, the interval of increasing is 0 to pi. Choice C. Question number 22. Find on which interval the function is increasing. Find the derivative of this function. The first function, find the derivative times the derivative of the second, plus the second function times the derivative of the first. Set it equals 0, factorize by e to the x, 1 x plus 1 equals 0. E to the x never been 0, then x plus 1 equals 0. Therefore, x equals negative 1 is a critical point. Find the sign of the derivative. This is negative 1. Before negative 1, take negative 2 and find the derivative. Negative 2, e to the negative 2 plus e to the negative 2 equal to negative 2 over e to the 2 plus e to the 1 over e to the 2. Negative 2 over e to the 2, it's greater than 1 over e to the 2. Therefore, this sign here is negative. When x greater than negative 1, take 0. 0 times e to the 0, 0 plus e to the 0, 1. Therefore, here the interval is increasing. And therefore, the increasing interval is negative 1 to positive infinity over interval, open interval. Choice B. Question number 23. Find the local minimum point of the function f of x equal x power 3 over 3 minus x power 2 minus 3. F prime of x equal to 3x power 2 over 3 minus 2x minus 3. Reduce x3 with 3, set it equals 0, then x power 2 minus 2x minus 3 equals 0. Analyze by experiment. X, negative 3 plus 1 equal 0. Either x equal 3 or x equal negative 1. We find the sign of the derivative before and after the critical point. This is -1 and this is 3. Before -1, take -2. This is the derivative. -2 square, 4, plus 4, 8, minus 3, it is positive value. Between -1 and 3, take 0. 0 minus 0 minus 3, it is negative value. Greater than 3, take 4. 4 power 2, 16. 16 minus 8. 8 minus 3, it is positive value. Therefore, -1 is maximum local point and x equal 3 is local minimum point. Therefore, 3, -9 is the right choice A. Question number 24, the function f of x equal x power 2 minus 6x plus 8 at the point 3, -1 has an inflection point or local minimum or local maximum or none. F prime of x equal to 2x minus 6. Set it equals 0, factorize by 2, x minus 3 equals 0, therefore x equals 3 is critical point. Let us see x equals 3 is an inflection, minimum or maximum local point by finding the derivative, the sign of the derivative of this point before and after 3. Before 3, take 0, the value of the derivative is negative, the sign of the derivative is negative. After 3, take 4, 2 times 4, 8 minus 6, 2, the value is positive. Therefore, the function has local minimum point at x equal 3, -1. The right choice is B. Question number 25. Which function has exactly two local extremum? For the first function, x minus 2, if we rewrite this function as piecewise function, it is x minus 2 when x greater than or equal to negative x minus 2 when x less than 2. And its derivative is 1, -1 when x greater than 2, x less than 2. Therefore, this function has one critical point and therefore one local extremum. For the second function, the derivative of this function is 3x power 2 minus 6. Set it equals 0. This function factorized by 3, x minus 2 equals 0. Sorry, x power 2 minus 2 equals 0. X equal negative positive square root 2. This function has two local extremum. So it is the right choice. For the third function, the derivative of the function is 3x power 2 plus 6, set it equals 0, factorized by 3, x plus 2 equals 0, x power 2 plus 2 equals 0, x power 2 equals -2, and x equals negative positive square -2, not a real number. This function has no local extremum point. Also, tan x has no local extremum point since the derivative of this function is 1 over cosine square x, set it equals 0, then cosine square x equal, then cross multiplication, 1 equals 0, contradiction, there is no local minimum point, and the value make the denominator 0 are pi over 2, 3 pi over 2, and so on. And these points are not in the domain of this function, since tan is sine over cosine. And the value make cosine 0 is not in the domain of the tan. Therefore, the right choice is B. Question number 26. Which function has exactly two local extremum? We check the function f of x equal tan x in the previous question. For the first choice, the derivative is 3x power 2 plus 4. Set it equals 0. Then 3x power 2 equal negative 4. Then x power 2 equal negative 4 over 3. This give you x equal to negative positive square root negative 4 over 3, not a real number. Therefore, this choice is also wrong. The derivative of this function is 1 plus 1 over x. Set it equals 0. Then 1 over x equal negative 1. Cross multiplication, x negative x equal 1. Then x equal 1. There is 1 local extremum to this function. So also this is wrong for this function. 3x power 2 minus 6 is the derivative of this function. Factorized by 3, x power 2 minus 2 equals 0. Then x power 2 equals 2. Then x equal negative positive square root 2. There is 2 local extremum to this function. Therefore, it is the right choice. Question number 27. Which function has exactly one local extremum? Tan x has no local extremum. We checked it before. X power 3 minus 6x plus 5. We check it in question number 27, has two local extremum, so it's wrong. X power 3 plus 6x minus 5. We check it, also no local extremum. So also this choice is wrong. Therefore, the right choice is C. Let us check it. The derivative of this function is negative 2x. Set it equals 0. Then x equals 0 is a critical point for this function, and it is local extremum. If we check the sign of the derivative before and after this point, when x is negative 1, then the derivative is positive, and when x equal 1, the derivative is negative. Therefore, x equals 0 is local maximum point. Question number 28. Which function has exactly two local extremum? This function has one local extremum at x equal 3. Let us check the second function. The derivative is 3x power 2 minus 12. Set it equals 0. Factorized by 3. X power 2 minus 4 equals 0. X equal negative positive 2 are critical point. Therefore, it has two local extremum. Let us check that third function. 3x power 2 plus 12 equals 0. Factorized by 3, x power 2 plus 4 equals 0. X power 2 plus equal to negative 4, x equal to negative positive square root negative 4, not a real number. Therefore, this choice also is wrong. Ln x, the derivative of it is 1x of equals 0, 1 equal 0, contradiction. This function has no local extremum. The right choice is B. Question number 29. Which of the following achieves the function f of x equal 2x power 3 plus 3x power 2 minus 12x? Let us find the derivative of this function. F prime of x equal to 6x power 2 plus 6x minus 12. Set it equal 0. Divide by 6. X power 2 plus x minus 2 equals 0. Analyze by experiment. X plus 2, x minus 1 equal 0. Then x equal negative 2 and x equal negative 1 are the critical point for this function. Let us find the derivative, the sign of the derivative before and after this point. When x is less than negative 2, negative 3 power 2, 9, 9 minus 5, positive value. When x between negative 2 and negative 1, negative, and 1, take 0, the sign is negative. When x is greater than 1, take 2, 6 times 4, 24, it is positive value. Therefore, the possible right choice is, the right choice is C. Negative 2, 1 are only appear in choice C. Question number 30. Find the interval on which f of x is decreasing. F of x equal x minus 4 square root x plus 1. F prime of x equal to 1 minus 4 1 over 2 square root x plus 1. Set it equal 0 and simplify it. 2 with 4, 1 minus 2 over square root x power 1 square root x plus 1 equal 0. Therefore, 1 equal to 2 over square root x plus 1. Cross multiplication. Then square root x plus 1 equal to square both sides. X plus 1 equal 4. Therefore, x equal 4 minus 1, 3 is a critical point for this function. And also, negative 1 is a critical point for this function since the derivative is not defined at negative 1, and negative 1 is within the domain of this function. Therefore, we set negative 1 and 3, find the sign of the derivative before negative 1 and after negative 1, before 3 and after. Before negative 1, the domain is not defined. We will find between negative 1 and 3, 0, take 0. The derivative is 1 minus 2 over 1, negative 1. So here the function, the derivative of the function is negative. When x greater than 3, take 8, 8 plus 1, 9, square root 9, 3, 2 over 3, 1 minus 2 over 3, it is positive value. Therefore, the decreasing interval is from negative 1 to 3 open interval. Choice A. See you next lesson.